All right, in problem number 42 of section 2.2, we're asked to look at a physical quantity called work, which is defined as the product of displacement times force. We're assuming that we have an object acted on by a constant force, and we have a function p of t giving the position of the object in meters. Now, part A asks us to write a formula for the rate of change of work, which also goes by the name of power. So, see from over here that work is given as, well, the product of force times displacement, so F times P of t minus P of 0, position at time 0. Now F is constant, and here we can just apply linearity to see that this is going to be the derivative of the first part, P of t, so P prime of t minus P prime of P of 0, which is just a constant. So the rate of change of work is equal to force times the derivative of the position function, but the instantaneous rate of change, or the derivative of the position, is just velocity. So we see that the rate of change of work is just given by the constant force. If the object is being acted on by a constant force, is just given by F times the velocity at that time. And this should be the velocity at time t. So for part B, we're given the a function, a quadratic modeling the position of our object, and we're asked to find the rate of change of work done the rate of change of work done by a 16 Newton force. So we know that the rate of change done at time t is going to be equal to the force times the derivative of P of t. So this is going to be equal to 16. Now the derivative is just going to be 2t plus 4. Which is equal to 32t plus 64. Now we're asked to find this, and we want to evaluate this at time t equals 20 seconds. So at time t equals 20 seconds, the rate of change of work being done, or the power, is going to be 32 times 20 plus 64, which is equal to 640 plus 64, or 704.